Welcome to the deep dive. Today, we're going kind of behind the scenes, of something you use every single day. Software. Ever wonder what makes an app run smoothly?
Yeah.
Or, conversely, why some are so glitchy? We're going to explore that.
It's more than just about making sure things don't crash.
Right.
It's about the whole process of building software that's, well, reliable,
Sure.
efficient, and does what it's supposed to.
Right. And to do that, we're diving into some course notes for a class called Calitate I Testare Software.
Okay.
That's Romanian for software quality and testing.
Interesting.
It's like our cheat sheet for understanding the building blocks of good software.
I like it.
And to kick things off, let's think about why this even matters.
Right.
We all use apps for banking, navigation, even just checking the weather.
Yeah.
Oh, tell me about it. I once got caught in a downpour because a weather app swore it was partly cloudy.
Exactly.
Right.
But think about it.
Yeah.
Poor quality software can lead to more than just soggy shoes.
Oh, for sure.
It can mean financial losses if a banking app malfunctions.
Oh, yeah.
Or even security risks if your data isn't properly protected.
That's true.
Our source material actually points out that for companies, this stuff is about reputation too, not just technical glitches.
That's a really good point.
Yeah.
It's easy to forget that there are real-world consequences to buggy software. It's not just a minor inconvenience.
Absolutely. And it goes beyond just the user experience.
Right.
Developers themselves benefit from a focus on quality.
Okay.
If you're the one who has to fix poorly written code,
Yeah.
it becomes a nightmare, it's inefficient,
Sure.
and can lead to a lot of late nights.
Yeah, I can imagine.
Yeah.
So how do developers actually ensure quality?
Well,
Is it all about just, not making mistakes when writing code?
it's definitely more nuanced than that.
Okay.
The course notes we're looking at actually highlight several key concepts that contribute to software quality.
Okay, let's unpack this a little.
Sure.
What are some of those concepts?
Well, one fundamental concept is version control.
Yeah.
Using systems like Git.
Okay.
Think of it like track changes for code.
Hmm.
It lets developers collaborate on projects,
Right.
track every modification,
Wow.
and even revert back to older versions if needed.
That's super interesting. It sounds like version control is crucial,
Yeah.
especially when you have multiple people working on the same project.
For sure.
Is it really like a time machine for code, though?
It really is.
Wow.
It allows you to go back and see exactly who changed what and when, which is invaluable for debugging and understanding the evolution of a project.
Right.
And beyond collaboration, imagine accidentally deleting a chunk of code.
Oh, no.
Version control lets you restore it without pulling your hair out.
Wow. Okay, I'm starting to see the appeal. What else is in this quality toolkit?
Another key concept is the idea of clean code.
Okay.
It's a set of principles for writing code that's easy to read,
Sure.
understand,
Yeah.
and maintain, not just for the original developer,
But for anyone who might work on it later.
That makes sense, but let's be honest.
Yeah.
Sometimes deadlines are tight.
Sure.
Why should developers prioritize writing clean code when they're under pressure to deliver features quickly?
That's a fair question.
Yeah.
It might seem like extra effort up front,
Right.
but trust me,
Okay.
clean code pays off in the long run.
Okay.
Think about it.
Yeah.
If you have to go back and fix a bug in a messy,
Yeah.
convoluted code base, it's going to take you way longer than if the code was clear and well organized from the start.
Right.
There's a great quote from Robert C. Martin that I think captures this perfectly.
Okay.
The only way to go fast is to go well.
The only way to go fast is to go well. I like that. So investing in quality up front actually speeds things up down the line.
Absolutely.
And for anyone who wants to see the real-world impact of neglecting quality,
Yeah.
there's a great blog post linked in the course notes.
Okay.
I'll make sure we include the link in the show notes for you to check out. Definitely.
And speaking of things that might seem like extra effort but are totally worth it,
Yeah.
let's talk about design patterns.
Okay.
All right, design patterns.
Yeah.
From what I gather, these are like prefabricated solutions to common problems in software design.
Yes.
Almost like having blueprints, right?
Exactly.
Okay.
Imagine you're building a house.
Okay.
Instead of figuring out how to build a door from scratch every time,
Yeah?
you use a pre-designed door frame that's already been proven to work.
Sure.
Design patterns are similar.
Okay.
They provide reusable solutions that make code more efficient, robust, and easier to understand.
Okay, that analogy makes it much clearer. So are there a ton of these design patterns out there?
There are quite a few, yes.
Okay.
And the course notes actually list out a whole bunch.
Okay.
Singleton factory method,
Well,
prototype builder, adapter.
Wow.
The list goes on.
Wow, that's a lot.
Yeah.
If I'm being honest, that sounds a bit overwhelming. Is it really necessary to learn every single pattern?
Don't worry, it's not about memorizing every single one.
Yeah.
It's more about understanding the underlying principles.
Right.
And recognizing when a particular pattern can be applied to solve a specific problem.
Okay.
Think of it like having a toolbox full of different tools.
Yeah.
You don't need to use every tool for every job.
Right.
But it's helpful to know what each one does and when it's the right fit.
That's a great way to put it.
Yeah.
So it's about building up a repertoire of solutions and knowing which one to pull out when you encounter a particular challenge.
Precisely.
And speaking of recognizing patterns, there's another crucial concept we should touch on. Unit testing.
Okay.
Okay, unit testing. We briefly talked about this earlier.
Yes.
But I'm ready to dive a bit deeper.
Okay.
What's the big idea behind unit testing?
Think of unit testing as a way to check individual parts of your code. Like making sure each brick in a wall is strong and stable before you build any higher.
So it's like a safety check for each component of the software.
Right.
Ensuring that everything works as expected in isolation.
Exactly.
Okay.
It involves writing small, focused tests that verify the behavior of individual functions, methods, or classes.
Okay.
This helps catch bugs early on,
Right.
preventing them from becoming bigger problems down the line.
That makes a lot of sense.
Yeah.
It's like finding and fixing a crack in a bridge before it's open to traffic.
Exactly.
But how do we actually write these tests?
The course mentions a framework called Junit, which is widely used for writing unit tests in Java.
Okay.
It provides a structured way to define tests, run them, and analyze the results.
Okay.
There's also the concept of assertions, which are basically checks to ensure the code is producing the correct output.
So Junit is like the testing ground, and assertions are the rules of the game.
That's a great way to think about it.
Okay, cool.
And to make these tests even more powerful, we have things called mocks.
Okay, mocks.
They're like stand-ins for real components that our code might interact with.
Wait, so we're basically tricking our code into thinking it's talking to the real deal. Why would we do that?
It's all about control and isolation.
Okay.
By using mocks, we can simulate the behavior of other parts of the system without actually depending on them.
Okay.
This makes our tests more reliable and easier to manage.
Gotcha.
Imagine you're testing a function that sends an email.
Right.
You don't want to actually send an email every time you run the test.
Right. Cool.
Instead, you can use a mock to simulate the email sending process.
Okay.
And verify that your function is doing what it's supposed to.
Ah, that makes sense.
Yeah.
It's like creating a mini controlled environment where we can really put our code through its paces.
Exactly.
And this focus on testing early and often leads us to another interesting shift in the world of software development. A shift that challenges the traditional roles of developers and testers.
Yeah.
Okay, now I'm really intrigued. It sounds like we're about to delve into some juicy behind-the-scenes drama in the world of software development. Tell me more about this shift.
Well, traditionally, there was a clear division between developers who wrote the code and testers who, tested it.
Right, right.
It was almost like two separate teams working independently. But nowadays, there's a growing trend towards a more integrated approach. Where developers are responsible for testing their own code.
That's interesting.
Yeah.
So it's less about throwing code over the wall to a separate testing team.
Right.
And more about everyone working together on the same team towards the same goal of quality.
Exactly.
And this is where the course notes get really visual.
Right.
They show a simple image labeled tester, representing the traditional role.
Right.
And then another image labeled dezvoltate high tester, which means developer and tester, symbolizing this combined role.
I see.
It's a subtle, powerful message. We're all responsible for quality.
Absolutely.
It sounds like there's a big shift in mindset.
It is, and it's a shift that's driven by the need for faster development cycles and more reliable software.
Okay, so we've talked about version control, clean code, design patterns, and unit testing.
Right.
All crucial elements of building quality software.
Yeah.
But if someone were to take this course we're looking at, what would they actually walk away with?
Well, first and foremost, a deeper understanding of the software development process itself.
Sure.
They would gain practical skills in writing cleaner, more testable code. And a greater appreciation for the complexity behind the apps we use every day.
That makes sense.
Yeah.
I feel like we've only just scratched the surface here, though. There's still so much more to explore in this world of software quality and testing.
Absolutely.
And that's the beauty of it. There's always more to learn.
For sure.
But before we get ahead of ourselves,
okay,
why don't we take a closer look at those intriguing design patterns we mentioned earlier?
Great idea.
I'm ready to unlock the secrets of these software blueprints. But before we do, let's take a quick break to recharge our brains.
Okay.
We'll be back in a flash to delve into the fascinating world of design patterns.
Sounds good.
All right, we're back.
Yeah.
And ready to tackle those design patterns we touched on before.
Okay.
They're like having a toolbox of solutions for common coding problems, right?
Exactly.
Okay.
Think of it like this. Let's say you're building a website.
Yeah.
And you need a way to let users log in.
Okay.
You could write the code for this from scratch each time.
Right.
Or you could use a pre-designed pattern,
Yeah.
like a template, that already handles all the tricky parts of authentication.
Right.
That's what design patterns do for developers.
So it's about working smarter, not harder.
Exactly.
I like it. But with so many patterns,
Yeah.
where do we even start?
Well, the course notes actually list a bunch, which can seem overwhelming.
Right.
But it's more about understanding the core ideas
Sure.
and recognizing when a specific pattern is the right tool for the job.
Okay, so less memorization,
Yeah,
more understanding the why behind each pattern.
exactly.
I like
It's about having that toolbox and knowing which tool to grab.
Gotcha.
Let's look at a few examples to make this more concrete.
Perfect. Give me a taste of this design pattern thinking.
Okay, let's start with the singleton pattern.
Okay.
Imagine you have a resource that needs to be accessed by multiple parts of your code,
Okay.
but you only want one instance of it to exist. Think of a shared printer on a network.
Okay.
Everyone needs access, but there's only one physical printer.
Right.
The singleton pattern makes sure there's only one printer object in your code,
Okay.
preventing conflicts and ensuring consistency.
That's a great analogy.
Yeah,
So it's all about managing shared resources carefully.
absolutely. Now let's jump to another pattern, the factory method.
Okay. The factory method.
This one's about creating objects without specifying the exact class of object that will be created.
Okay. That sounds a bit abstract.
Yeah.
Can we bring this down to earth with an example?
Sure.
Okay. Imagine you're building a game,
Okay.
and players can choose from different character types.
Okay.
Warriors, wizards, archers,
Right.
and so on.
Yeah.
The factory method lets you define a character factory
Okay.
that can create any of these types based on the player's choice.
Okay.
It's like a character creation machine.
I like that.
Yeah.
Okay.
Just input the type you want, and out pops a fully formed character ready to play.
That's so cool. So as the
Like-
game developer,
Yeah.
you don't have to hard code each character type separately. You have this flexible system that can handle new additions easily.
Exactly.
Awesome.
It makes your code adaptable, which is crucial in a dynamic environment like game development. This is making me realize that there's a lot more thought and strategy that goes into software development than I initially realized.
Absolutely.
It's not just about writing lines of code.
Yeah.
It's about designing elegant solutions that are flexible and efficient.
You got it.
Okay, cool.
And that's the beauty of design patterns.
Yeah.
They're born out of experience from developers solving similar problems over and over again. It's like collective wisdom distilled into these reusable patterns.
Okay. I'm sold on the idea of design patterns, but how do I know which one to use when? Is there a secret decoder ring for this?
There's no magic formula, unfortunately. It
Right.
comes with experience and understanding the nuances of each pattern.
Right.
But the good news is that there are tons of resources out there to help you.
Okay.
This course even points to a website full of information on software development and design patterns.
Perfect. I'll definitely be checking that out.
Yeah.
So we've talked about singleton and factory method. What other gems are hidden in this design pattern treasure chest?
We've got the prototype pattern,
Okay.
which is all about cloning existing objects to create new ones. Then there's the builder pattern for constructing complex objects step by step.
Okay.
And the adapter pattern,
Right.
which helps connect incompatible pieces of code.
It's like there's a design pattern for every situation. I'm starting to see these patterns everywhere now, even in non-coding contexts.
That's the power of recognizing patterns.
Yeah.
It's about understanding the underlying principles
Right.
and applying them to solve problems in a more elegant and efficient way.
Well, I'm feeling inspired to dive deeper into these design patterns. But for now, let's shift gears back to the essential world of testing.
Okay.
Talked about unit testing earlier,
Yeah,
but I have a feeling there's a lot more to uncover there.
you're absolutely right.
Okay.
Unit testing is like the foundation of a solid software structure. And we've only just laid the first few bricks. Let's explore what makes a unit test truly effective.
I'm all ears. Let's build this foundation of knowledge, brick by brick. Welcome back to the Deep Dive. We've been exploring this world of software quality and testing.
Yeah.
And now it's time to really put those testing skills under the microscope.
Indeed. We've talked about unit testing as a way to catch those errors early on.
Right.
Remember that analogy of spotting cracks in a bridge before it's open to traffic?
Oh, yeah, for sure.
But now, let's dig into what makes a good unit test truly stand out.
Okay, I'm ready to get specific. What are the golden rules of effective unit testing?
Well, first and foremost, a good unit test should be laser-focused.
Okay.
It's about testing one tiny piece of your code in isolation, like putting a single line under a magnifying glass.
Oh.
We want to see exactly how it behaves, make sure it does its job, and nothing more.
So it's not about testing the entire application at once.
Right.
But breaking it down into these tiny, manageable pieces.
Precisely. And this isolation is key for a few reasons. If the test fails, we know exactly where to look for the problem.
Right.
Plus, it keeps our tests fast and efficient.
Makes sense. It's like a detective focusing on one clue at a time.
Yeah.
Instead of trying to solve the entire case all at once.
Exactly.
But how do we achieve this level of focus in our tests?
That's where those mocks we talked about earlier come in handy.
Right, the mocks.
Remember how we can use them to simulate the behavior of other parts of the system?
Yeah.
Well, this helps us create a controlled environment for our unit tests.
Okay.
So we can really isolate the piece of code we're testing.
Right. So it's like setting up a mini stage for our code to perform on,
Okay.
where we control the lighting, the props, everything.
Yeah.
We can set up these specific scenarios and see how our code reacts without worrying about external factors.
You've got it.
Yeah.
We can provide specific inputs and then check if the output matches what we expect.
Right.
It takes out a lot of the guesswork and makes our tests super reliable.
This is making me think about those scientific experiments where they try to isolate variables to see the true cause and effect.
Yeah.
Is unit testing kind of like that?
It absolutely is.
Cool.
And another crucial principle in both science and unit testing is repeatability.
Okay, repeatability.
A good unit test should produce the same results every single time, no matter who runs it or what environment it's run in.
So consistency is key.
Exactly.
We don't want our test to be flaky or unreliable.
Right.
We need to be able to trust those results.
Exactly. This consistency allows us to build a safety net of tests that we can rely on as our code base grows and changes.
Okay.
We can confidently make updates and improvements,
Right.
knowing that if anything breaks, our tests will immediately sound the alarm.
It's like having a team of tiny robots constantly checking our code for errors.
Yeah.
So unit testing isn't just about finding bugs.
Right.
It's about preventing them in the first place and giving developers peace of mind.
Exactly. And this brings us back to that shift in mindset we discussed earlier, where developers are taking on more responsibility for testing their own code.
Yeah.
Unit testing is a crucial part of this shift.
Right. It's no longer about a separate team of testers catching errors at the end of the development process.
Yeah, exactly.
It's about integrating those quality checks throughout the entire journey.
Precisely. And unit testing empowers developers to do just that. By writing tests as they code, they're building quality into the software from the ground up.
Right.
It's like checking your work as you go instead of waiting to the very end to see if you made any mistakes.
It sounds like unit testing is a win-win.
Absolutely.
It helps developers create more robust software, and it gives them confidence in their work.
Exactly. And ultimately, that's what this whole deep dive into software quality and testing has been about.
Yeah.
Showing you the thought, care, and precision that goes into building the software we use every single day.
It's been a fascinating journey. We've gone from the high-level why of software quality to the specific techniques, like design patterns and unit testing.
Yeah.
And I feel like I've gained a whole new appreciation for the complexity and artistry behind seemingly simple apps.
I'm glad to hear that. And remember, this is just the beginning.
Right.
The course notes we explored today are full of additional resources for you to dive even deeper into these concepts.
Yes. To all our listeners out there, think about the apps you use every day. Now imagine you could peek behind the scenes and see all the careful planning, testing, and refining that went into making them work seamlessly.
Absolutely.
That's the power of understanding software quality and testing.
For sure.
It gives you a whole new perspective on the digital world around you.
And it might even inspire some of you to explore the world of software development yourselves.
Absolutely. Well, on that note, we've reached the end of our deep dive.
Okay.
We hope you've enjoyed the journey as much as we have.
Yeah, thanks for listening.
Until next time, keep exploring, keep learning, and keep those apps running smoothly.